Class 8 Physics.
Measurement. Measurement is the process of finding an unknown physical quantity using a standard quantity. For perfect measurement, we need three things. First, an instrument. A standard quantity. And an acceptable unit. For example, we can consider a book. Here, let us find the length of this book. Here, L is the unknown physical quantity. So, we need to find this unknown physical quantity using a standard quantity. For this, we need an instrument. Let this be a ruler. This ruler is in centimeter. So, let us assume that L is equal to 15 centimeter. That is, the unknown physical quantity L is 15 centimeter. Here, 15 is the magnitude and the centimeter is the unit. So, this process is called measurement. Here in this, we are finding the unknown physical quantity using a standard quantity. So, this process is called measurement. So, for measurement, what all things we need? An instrument, a standard quantity and an acceptable unit. Here, L is the physical quantity, unknown physical quantity. For that, we have received 15 centimeter, where centimeter is the unit and 15 is the magnitude.
Measurement. Measurement is the process of finding an unknown physical quantity by using a standard quantity. For a perfect measurement, we need three things. 1. Instrument. 2. A standard quantity. 3. An acceptable unit.
Measurement. In this system of units, some of the common systems of units are the FPS system, CGS system and MKS system. Here in this FPS system, F represents foot, P pound and S second. So FPS is foot, pound and second. This foot is for length. Pound is for mass and S is for time. Similarly, in CGS system, CGS and denotes centimeter, gram and second. This is also for length, mass and time. Next is the MKS system. This MKS system represents M, K and S represents meter, kilogram and second. This is also for length, mass and time. So these are the three common systems we are using. That is FPS system, CGS system and MKS system. This CGS system, MKS system and SI units, these are all metric systems. or metric system. This FPS system is not a metric system. It is a British system of units. This is British system of units. This is not a metric system. So, this system differs from CGS, MKS and SI units.
System of units. FPS, foot for length, pound for mass and second for time. CGS, centimeter for length, gram for mass and second for time. MKS, meter for length, kilogram for mass and second for time. CGS, MKS and SI units are metric systems of units. FPS is not a metric system, it is a British system of units.
SI units. SI is the International System of Units. SI units is the International System of Units. This abbreviation is abbreviated from the French name System International. So, under SI units, 7 physical quantities were selected as base quantities. They are length, mass, time, temperature, electric current, amount of substance and luminous intensity. So under SI system, the scientists in France in the year 1960, they selected 7 physical quantities as standard base quantities. So they are length, mass, time, temperature, electricity, amount of substance, and luminous intensity. So in this, the 7 physical quantities that have been selected as base quantities are length, mass, time, temperature, electricity, amount of substance and luminous intensity. So again, for every base quantity, a standard unit was defined. So for length, the standard unit defined was meter. For mass, kilogram. For time, seconds. For temperature, Kelvin. For electricity, ampere. For amount of substance, mole, MOL. And for luminous intensity, it is candela, CD. So these units are called SI units, and they are the base units and also called the fundamental units. So these are the fundamental units or the base units for the base quantities: length, mass, time, temperature, electricity, amount of substance and luminous intensity. So what is SI unit? SI unit is the International System of Units. It is abbreviated from the French name System International. So the scientists in France in the year 1960 at Paris during a conference, they selected 7 physical quantities as base quantities. So they are length, mass, time, temperature, electricity, amount of substance and luminous intensity. Then for every physical quantity, that is for every base quantity, a standard unit was defined, that is meter, kilogram, second, Kelvin, ampere, mol for mole, then candela, CD.
SI units. SI units are International System of Units. SI is abbreviated from the French name System International. 7 physical quantities were selected as base quantities and a standard unit was defined to measure each one. They are known as base units or fundamental units. Table 1. Base quantities and units. Quantity, unit, symbol. Length, meter, m. Mass, kilogram, kg. Time, second, s. Temperature, Kelvin, K. Electric current, ampere, A. Amount of substance, mole, mol. Luminous intensity, candela, CD.
Temperature is a physical quantity that expresses the degree of hardness or coldness of a substance. Let us consider a vessel containing water. So, in this, if you give some heat to this substance, that is the water, the temperature of the substance will increase. So, if heat is given to a substance, the temperature increases. Yeah. Similarly, if heat is removed from a substance, the temperature of the substance will reduce. Temperature of water. Let us consider water is the substance inside the vessel. So, in this vessel, we have taken some water. We are giving heat to it. Automatically, the temperature of the water increases. If you remove heat from water by keeping it in a refrigerator, automatically the temperature reduces. So, we can define temperature as a physical quantity that expresses the degree of hardness or coldness of a substance. So, how can we define temperature? Temperature is defined as a measure of average kinetic energy of particles in a system. Every substance consists of particles. If you heat something, automatically the kinetic energy of the particle increases and automatically the temperature increases. So we can define temperature as a measure of the average kinetic energy of the particles in a system. So The SI unit of temperature is Kelvin. What is the SI unit of temperature? It's Kelvin. For measuring temperatures, thermometers are used. For measuring temperature, thermometers are used. Celsius, Fahrenheit and Kelvin are the different scales. These are the different scales of measure in thermometers. Celsius, Fahrenheit and Kelvin are the commonly used scales to measure temperature using thermometers. LFP and UFP. What is LFP? Actually, LFP is the lower fixed point and UFP is the upper fixed point. This denotes the lower fixed point and this is the melting point of ice. And it's 0 degrees C. So the lower fixed point, that is LFP, is 0 degrees C. UFP is the upper fixed point. This is the boiling point of water. UFP is the boiling point of water and it is 100 degrees C. So, the SI unit of temperature is Kelvin. Thermometers are used for measuring temperature. The scales used in thermometers for measuring temperature are Celsius, Fahrenheit and Kelvin. LFP and UFP are the lower fixed points and the upper fixed points. What is the lower fixed point? Lower fixed point is the melting point of ice, that is 0 degrees C, and the upper fixed point of water, that's the boiling point of water, is 100 degrees C. We can tabulate the various scales of measure. The various scales to measure temperature. What are the various scales? Celsius, Fahrenheit and Kelvin. So for this we are going to find out this LFP, UFP and also the number of divisions in the scale. So, what is the LFP for Celsius scale? That is 0 degrees C. UFP is 100 degrees C. That is the boiling point of water. The number of divisions in the Celsius scale is 100. In Fahrenheit scale, the LFP is 32 degrees C. 32 degree F. UFP is 212 degree F. And the number of divisions in the scale is 180. In Kelvin scale, the LFP is 273 K, UFP is 373 K and the number of divisions in the scale is 100. So these are the various scales to measure the temperature: Celsius, Fahrenheit and Kelvin. The LFP for Celsius is 0 degree, UFP is 100 degree and the divisions is 100. For Fahrenheit it's 32 and UFP is 212 and the number of divisions is 180. Again in Kelvin it's 273 for LFP, UFP is 373 Kelvin and the number of divisions is 100. The general formula for the conversion of scales of temperature is the general formula for the conversion of scales of temperature is C minus 0 by 100 is equal to F minus 32 by 180. This is equal to K minus 273 by 100. So this is the general formula for conversion of scales. The next is the application. The uses of thermometers. So thermometer is used to measure the temperature of any substance. So physicians, who are the physicians? They are the doctors. They use clinical thermometers. And this is in degree Fahrenheit. So physicians use clinical thermometers and this is in degree Fahrenheit. This is in Fahrenheit scale. Scientists, they use thermometers in Kelvin scale. The next is the common thermometer, common measurements. Common measurements are made using thermometers in Celsius scale. For example, we can say weather reports. We measure weather reports in Celsius scale. So physicians use clinical thermometers. It is in Fahrenheit scale. Scientists use thermometers in Kelvin scale. And common measurements are made using thermometers in Celsius scale. For example, we can say weather reports. Some general information. Normal temperature. What's the normal temperature of human body? Normal temperature of human body is between 98 degree Fahrenheit and 98.6 degree Fahrenheit. So normal temperature of the human body is between It's between 98.4 degree Fahrenheit and 98.6 degree Fahrenheit. Again, another one thermometer is there. It's the infrared thermometer. What is the purpose of this infrared thermometer? What is the speciality in this? Actually, this thermometer can be used to measure the temperature of any object without any physical contact with it. So, without physical contact with an object, the temperature of the object can be found using this thermometer. Without any physical contact with the object, the temperature of the physical object can be found using this infrared thermometer. This is the speciality in this. So here, what are the information here? That is, normal temperature of human body is between 98.4 degree Fahrenheit and 98.6 degree Fahrenheit. Infrared thermometer is a thermometer that can be used to measure any object without any physical contact with that object. That's all.
Temperature. Temperature is a physical quantity that expresses the degree of hardness or coldness of a substance. Heat given to a substance will increase its temperature. Heat removed from a substance will lower its temperature. Figure 1. Various hot and cold objects. A. Cold. B. Hot. C. Hot. And D. Cold. Definition. Temperature is a measure of the average kinetic energy of the particles in a system. SI unit of temperature is Kelvin. Thermometers are used for measuring temperature. Celsius, Fahrenheit, and Kelvin are the most commonly used scales to measure temperature. LFP and UFP. The melting point of pure ice, 0 degree C, is taken as the lower fixed point, LFP. The boiling point of water is taken as upper fixed point, UFP. Table 2. Various scales to measure temperature. Types of scale: lower fixed point LFP, upper fixed point UFP. Number of divisions in thermometer: Celsius 0 degree C, 100 degree C, 100. Fahrenheit 32 degree Fahrenheit, 212 degree Fahrenheit, 180. Kelvin 273 K, 373 K, 100. Conversion of scales of temperatures. The general formula for the conversion of scales of temperature is C minus 0 by 100 is equal to F minus 32 by 180 is equal to K minus 273 by 100. Application of various thermometric scales. Physicians use clinical thermometers in Fahrenheit scale. Scientists use thermometers with Kelvin scale. Common temperature measurements are made in Celsius scale. Example, weather reports. Infobits. Normal temperature of the human body is between 98.4 degree Fahrenheit and 98.6 degree Fahrenheit. Infrared thermometer measures the temperature of an object without any physical contact. Like and subscribe our channel for more informative videos. Thank you.